Hello students, in next topic of our mathematical physics we will see differential equations and what are differential equations and solution of these differential equations and what is degree or what is order of a differential equation. And after these basic things we will solve first order and second order differential equations. Now first we see that what are differential equations. So any equation containing the differential term like dy by dx or d2y by dx square or any higher order terms is called differential equation. So any equations containing these type of terms is called differential equation. So if you talk about the order and degree of any differential equation, order and degree. So the order is the highest differential term. So in an equation, the higher differential term is called order of that differential equation, and the power of that highest differential term, that higher differential term is called degree of that equation. So if you see by an example, so let you have a differential equation d2y by dx square plus d square y equal to 0. Now here you can see that the maximum differential term is d2y by dx square and its power is 1. So the order will be 2 and degree will be equal to the power of maximum differential term, which is 1. So in this equation, the order of this equation is 2 and the degree is 1. So now again you consider another equation, x square d2y by dx square whole cube plus y dy by dx whole power 4 plus y raised power 4 equal to 0. Now if you see this differential equation, so you can see that the maximum differential term here is d2y by dx square. So the order of this equation will be 2, and if you see that the power of maximum differential term, which is this d2y by dx square, is 3. So the degree of this equation will be 3. So if you discuss about degree of any differential equation, so if we must remove the radical sign and fraction of that term. So after removing the fraction or the radical sign of that term, you can define the degree of that equation. So if you discuss an example like 1 plus d2y by dx, sorry, dy by dx whole square and whole power 3 by 2 equal to d2y by dx square. Now here you can see that the differential equation has a fractional power 3 by 2. So to define the order and degree of this differential equation, we must remove the fractional power of this equation. So to remove the fractional power, which is 3 by 2, we will square the both sides of this equation. So the fraction power must be removed. So we will square both the equation and we will get dy by dx whole square whole power 3 equal to d2y by dx square and whole power 2. So now you see this equation. So this equation has not a frictional power. So you can define the order and degree of this equation. So if you see this equation, so the order of this equation will be 2 and the degree will also be 2. So by using this method you can apply, or you can know that what is the order and what is the degree of that equation. So one thing to remind is that the power must not be in fraction. So if the power is in fraction, you must remove the fractional part of that power, and now you can define the degree and order of that equation. So now the second topic we will see formation of differential equation. How can you formulate any differential equation by a given equation? Suppose now you have a function like y equal to ax plus a square. So you have to form a differential equation which satisfy this condition. So to form differential equation means you have to find out an equation which has solution like this. So to define the differential equation or to form any differential equation, you must remove the constants from these type of equations. So after removing constants like a or a square, you can define the differential equation for this equation. So to remove these constants, we will first differentiate this equation. So we will get dy by dx equal to a, and x has differentiation 1, and plus. So from here you got a equal to dy by dx. Now you can remove a by using equation number 2. So if you put value of a in equation first, you will get y equal to x into dy by dx plus dy by dx whole square. So this means if you solve this differential equation, you will get this type of solutions. And if you form differential equation by this equation, you will get this type of differential equation. So second example, if you see that we have to form differential equation for y equal to a cos x plus b sin x. So to form differential equation for this equation, we must remove this constant a and b. So to remove, first we will differentiate these equations. So we will get dy by dx equal to minus a sin x plus b cos x. Now again you cannot remove these two terms a and b. So to remove again these two terms a and b, we will again try to differentiate this equation. We will have d2y by dx square equal to minus a cos x and minus b sin x. Now if you take negative sign from this, you will get a cos x plus b sin x. Now if you see this term, this is equal to y. So by putting y instead of this, you can remove these two constants a and b. So you will have d2y by dx square equal to minus y, and if you write this equation in ordered form, you will get d2y by dx square equal to 0. So this means if you solve this type of differential equation, you will get solution like this, and if you have equation like this, you will have a differential equation like this. So both are complement to each other. Now let's consider a third example. We have given that y square equal to ax square plus bx plus c, and you have to define a differential equation with this condition. So to define differential equation whose solution is like this, you have to remove this term a, b and c. So first you will differentiate whole equation, and you will get 2y into dy by dx equal to 2ax plus b. Now we have again two coefficient a and b, and we must remove these two coefficient a and b. So we will again differentiate this equation. So if we differentiate this equation, we have two functions, one y and another dy by dx. So we will apply the product rule. So we will get 2y first function and differentiation of second function, which will be d2y by dx square, plus 2 second function dy by dx into differentiation of first function, which will be dy by dx. This will be equal to 2a. So again we have left a coefficient a, so we will remove this coefficient a by differentiating again, but we will first cancel out these two from all equations, and we will write this equation in little simplified way. So you can write this equation like dy by dx square equal to a. So you have to remove this term a, you will again differentiate this equation, so you will again put product rule, so you will get y into differentiation of second function plus second function into differentiation of first and plus differentiation of this term, you will get 2 dy by dx and again differentiation of dy by dx, so you will get d2y by dx square, and this will be equal to 0. Now we have removed all the coefficient a and b, so you can write this equation like y into d3y dx square plus you can add these two terms, you will get dy by dx into d2y dx square equal to 0. So this means these solutions are corresponding to this differential equation, or if you solve this differential equation anyhow, you will get such type of solution. So by using this method, you can form differential equation corresponding to any ordinary equation. So again we will do another example. Suppose you have given that xy equal to a exponential x plus b exponential minus x plus x square, and you have to formulate differential equation for this ordinary equation. So you have to remove these coefficients a and b. So to remove these coefficients, we will differentiate this equation, so we will get first function into differentiation of second plus second function into differentiation of first equal to a exponential x, and if you differentiate this, you will get b exponential minus x and plus 2x. So again we have coefficient a and b, and we cannot remove till the second step, so we will again differentiate this whole equation. So we will get x into d2y by dx square, again differentiating this equation, plus second function into differentiation of first plus differentiation of this equal to, you will get a exponential x, and if you differentiate this term, you will get b exponential minus x and plus 2. Now you can remove a and b by writing this term as this term from equation 1. You can write that xy minus x square. From here you can write this term as xy minus x square. So if you write like this, you will get x d2y by dx square plus you can add these two terms 2 dy by dx equal to xy minus x square plus 2. So if you remove, you write in more simplified way, you can write this d2y by dx square plus 2 dy by dx minus xy equal to 2 minus x square. So this means if you solve this type of differential equation, you will get such type of solution, or if you have such type of solution, so these solutions are the solution of this type of differential equation. So both are complementary to each other. So we will do another example. So you have, this is your fourth example. So you have a differential equation, a simple equation ax square plus by square equals 1, and you have to get differential equation for this ordinary equation. So we will write this as a 2ax plus 2by and dy by dx equal to 0. So you will have ax plus by dy by dx equal to 0. Again we have coefficient a and b. You will again differentiate this equation. You will get a plus b, and you have two functions, first one y and dy by dx. So if you differentiate and apply product rule, you will get y into d2y by dx square plus b and differentiation of first function and second function is equal to 0. So again you have coefficient a and b. You have to again differentiate this equation. So first you will write this in more simplified way. You will have d2y by x square plus b into dy by dx whole square. After writing this in more simplified way, you will again differentiate this equation. So you can remove the terms a and b. So again differentiating, you will get 0 by differentiating a, plus if you differentiate this equation you will get b. Again there are product of two functions, so you will get y into d3y by dx square plus b into second function into differentiation of first function, plus when you will differentiate this term you will get b into 2 dy by dx, and again if you differentiate this equation you will get d2y by dx square equal to 0. Now you can divide by b this whole equation, and if you see this term you will get y into d3y by dx square, plus you can add these two terms 3 dy by dx into d2y by dx square equal to 0. So this means if you have an equation like this equation will be solution of such type of differential equation. A and b may have different value, a may be 2, b may be 3, but this type of solutions are the solution of this